Hi, this is going to be an example of one of the topics from probability that gives people a lot of trouble, that's a little tricky to figure out, and we're going to go through it from top to bottom to do a problem like this. So this is an example of one of the medical testing and conditional probability problems. So let me read through the problem first, and then I'll talk about how we're going to solve it. So we've got a disease affects 0.03% of the population, and that's going to be important. I'll talk about why that is one of the spots that people get tripped up on in a bit. A test for the disease has a 4% false positive rate and a 2% false negative rate. What is the probability that someone who tests positive has the disease? Okay, this is a very typical kind of medical testing problem. There were some problems like this on homework 6 that people struggled with. And so let's go through this kind of step by step. Okay, so the first thing that you're going to do is you're going to start out with some total population. Okay, and so the number actually doesn't matter, but you should choose something fairly large. I'm going to start off with 100,000 people total. Okay, so 100,000 people in the population, and I'm going to use these percentages to figure out what percentage are in each group in this table based on the problem that we've got. Okay, so starting off, we've got 100,000 people, 0.03% of them have the disease. Okay, so that's going to tell us what fits in here, the total number of people who have the disease. Now, where people get tripped up is 0.03% sometimes gives us problems. Okay, so if you want to write 0.03% as a decimal, 0.03%, remember to write something as a decimal, you move the dot over 2 places to the left, right? And so 0.03% as a decimal is 0.0003, okay? Not 0.03. 0.03 is 3%, right? 0.3 is 30%. 0.3 is 30%, 0.03 is 3%, 0.003 would be 0.3%, so 0.03% is 0.0003, okay? And so we're going to take that times the total, 100,000, and get 30. If you multiply that out, you get 30, okay? So that tells us that out of these 100,000 people, only 30 of them actually have the disease. So this is a very rare disease. It's not something that a lot of people have. And that's going to affect our results a lot, okay, when we get to the end. Okay? So if 30 people have the disease, and there are 100,000 total, if we want to figure out how many people don't have the disease, that's pretty easy, right? Because these two numbers, this number and this number, have to add up to 100,000. So 100,000 minus 30, 99,970 is the number who don't have the disease total. Okay? So that's the first step to the problem, is kind of filling out this last column of the total people. To get the other values in here, we're going to use this 4% false positive rate and 2% false negative rate. Okay? And so if you remember from class, the false positive rate is going to be the number of people who don't have the disease and test positive divided by the number of people who don't have the disease. Okay? So it's the percentage of people who don't have the disease who test positive anyway. Okay? So in this case, that's going to give us the value here. The percentage of these 99,970 people who test positive even though they don't have the disease. Okay? So if we use that false positive rate, 4%, 0.04 of those 99,970 people are going to test positive. Okay? And that comes out to 3,998 0.8. Looking at my notes, I'm reading it wrong. So that number is going to go here. 3,999.8. 98.8. Make sure my numbers agree. So 3,998.8 people, 4% of those 99,970 test positive for the disease. Okay? Similarly, the false negative rate is the percentage of people who do have the disease but test negative. Okay? And so that's 2%. So 0.02 of the 30 people who have the disease are going to test negative. And if you multiply that out, that comes out to 0.6. Okay? Now, common mistake that I see my students make a lot is to say, oh, well, 0.6 of a person, that can't happen, right? So I'm going to round that to 1. Okay? And that's a bad kind of assumption to make, because these aren't really people, these are probabilities. So don't round these numbers too much. Just like with the financial formulas, if you round, you're going to make mistakes. It's not going to be quite right. I can show you kind of what would happen if we rounded these and how far off the percentage would be that we get at the end. Okay? But don't round. It'll only hurt you. Or round very little, right? So keep several decimal places, just like we did with the financial formulas. Okay? So we've got 0.6 who have the disease and test negative, 3998.8 who have the disease and don't have the disease and test positive, right, from our false positive and our false negative rate. To get the other values here, we're just going to do some subtraction, right? So the total is 30. We've got 0.6 who tested negative. That means the other 29.4, 30 minus 0.6, have to test positive. Similarly, and the arithmetic's a little bit more complicated here, if you take 99,970 minus this 3,998.8, you're going to get 95,971.2. These columns add up to our totals down here, which are 4028.2, this plus this, and 95,971.8 down here. And these numbers add up to 100,000 too, if you want to check. You can always check that and make sure that that works. Okay? So that's how you get this table. Now, once you've got the table, you can answer questions like the one that's given in the problem. Don't forget to do that. Sometimes on the homework, people finish this entire table, got it completely correct, and then didn't write an answer for the question. What is the probability that someone who tests positive has the disease? So remember, when we're talking about these probabilities, we have to think about what are we dividing by what? How do we get this value? So if they test positive, what's the probability that they have the disease? Okay? So we're looking at a probability out of all of the people who test positive. Okay? So in this example, what we're asking for here, we already know that they've tested positive. We want to know the probability that they have the disease. And so we're taking the probability by dividing by the number of people who test positive. What are we dividing by it? We're dividing the number of people who have and test positive. Right, have the disease. So we take the number of people who have the disease and test positive and divide by the number of people who test positive. And that's going to give us the probability that somebody who tested positive actually has the disease. If you divide that out, well, that top number, the number of people who test positive and have the disease, is 29.4. The number of people who test positive is this total value down here, 4028.2. Okay? And so we end up getting a probability of 0.0073, or if you want to write that as a percentage, 0.73%. Not 73%, 0.73%, right? Because it's 0.0073. Okay, so you have to be careful there. Don't miswrite it. Okay, so this is a very small percentage, right? Less than 1% of the people who tested positive actually have the disease. And if you look at it, it was only 29.4 out of the 4,000 people who tested positive who had the disease. Okay? And so what this shows us is that this isn't really necessarily a great test for the general population. It might be a good test for a smaller population if this number of people who had the disease were larger, right? Say if this were like 50-50, it might make a bigger difference. But in this case, it really isn't a great test, okay? And so that's going to be affected by all of these different numbers. And so looking at something like this, the probability that somebody who tests positive has the disease gives you a feel for kind of how good this test is.